Hello everyone. In this video, we will discuss few assembly language programs regarding 8086. So let's see which example we have taken for this one example related to divide a 16-bit number by an 8-bit number. And we are writing the ALP for 8086 here. So divide a 16-bit number by an 8-bit number. So first of all, we have to move one given number into the accumulator of 8086. So the first instruction is move AX 1V25 hexadecimal number to move into the accumulator. And this number is an 16-bit number. And we want to divide this 16-bit number by an 8-bit number. And we have taken the 24 hexadecimal number to divide this 16-bit number. So we have to move this 24 hexadecimal number into the register BL. So after moving the 16-bit number into AX and 8-bit number into BL, we have to use the division instruction, and it is an arithmetic instruction. So when we use division BL, it means we are dividing the content of accumulator by the content of BL. So in this case, we are dividing 1B25 hexadecimal number by 24 hexadecimal number. And the result, because the result for division operation gives two things. One is quotient and the second one is remainder. So whatever the content regarding quotient, it is saved into the lower byte of accumulator, means in AL, and whatever the remainder, it saves into the higher byte of accumulator into AH. So after executing this division BL, the quotient comes 193 in decimal, and hexadecimal it is equivalent to C1, and remainder is 1 here. So after executing this program, we get the content of accumulator as 01C1H. So this program is a sample program how we can divide a 16-bit number by an 8-bit number in 8086. Let's see the next example. This example related to calculate ones and twos complement of a 16-bit number. So first of all, we are writing the method to calculate ones complement directly. So we have chosen the same 16-bit number 1B25 hexadecimal for this sample program. So first of all, we have to move the 16-bit number into the accumulator. So we have used the first instruction. The second logical instruction use not AX. What is the function of not? Not function is it inverts the each bit. If we have 0, it inverts into 1. If we have 1, it inverts into 0. So we have also write this content of accumulator as in hexadecimal number, also in binary equivalent. Okay. So after executing not AX, you got your ones complement of the 16-bit number 1B25. So this is the method how we can directly calculate ones complement of a 16-bit number. In this case, we will see the direct twos complement of 16-bit number. So after moving the 16-bit number into the accumulator, we have to use one 8086 instruction that is called NEG neg, and we apply this on the content of accumulator. And what is the function of NEG? It directly provides you the twos complement of number whatever available into the accumulator. And this instruction used to deal with the negative numbers in 8086. So this is the instruction which provides you the directly twos complement of the number. After discussing these two direct matter, we can also calculate ones complement and twos complement indirectly using some other instructions. So how we can calculate ones complement, twos complement directly? So this is the indirect method to calculate ones complement of a 16 number. In the last example, we will see NEGAX returns the 2's complement directly. So if we subtract 1 from the 2's complement, we got our 1's complement. So this is the indirect method to calculate 1's complement. So first 16-bit number given into the accumulator, then we apply NEG to calculate 2's complement. Then we subtract 1 to get 1's complement. So this is the indirect ones complement method to calculate for 16-bit number. Now this is the indirect 2's complement. Indirect 2's complement of a 16-bit number. So in the previous example, we have apply not operation or not instructions to get ones complement. So to get ones complement, we can apply not operation, and after adding 1, we are able to get 2's complement for number. So I have incremented the content of accumulator, which is come after applying not operation. So after using this increment instructions, we get our 2's complement indirectly for a given 16-bit number instead of INC, because the purpose of increment instruction is just to add 1. We can also use for this purpose addition operation. So we can also replace this increment by add instruction. So this is indirect 2's complement method using add operation. So first of all, we have to move the 16-bit number into the accumulator, then apply not operation to get 1's complement, and after adding 1 into the content of accumulator, we get 2's complement. So this is the indirect method to calculate 2's complement of a 16-bit number. And in these in this given example, we have used the logical instruction, the arithmetic instruction, the data and copy transfer instruction, and the machine instruction in this case. So these few example given for the practice. And thank you for watching this video.